Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're here for the final segment of our low-cost 300B amp. And got just a little bit of wiring left to do on the output tubes. And I did listen to this amp and A-beat it with my OG 300B to just hear what was different between the two. And I'll cover that at the end of the video. But I just wanted to let you know, it did get burned in for about 6 hours before I listened to it and measured it. And I wanted to do my subjective listening before I measured it and had my view of what I was hearing biased. So let me show you the last little bit of wiring up the output tubes and the measurements, and then we'll do the final review. So let's go. Okay, so we're here to the easy part, which is wiring up the output tube. And first thing we did is, let me scoot this down, I'll show you a little bit on this. These are the B plus wires, or the positive leads of the output transformers. And I connected them to just a little single tag strip here to have a connection point. Then this is our high voltage DC that comes from this terminal over here. And I did do a little bit of computer sim work and realized that that 10 ohm resistor that I put across here was basically doing nothing. And so I went back to a 50 ohm 5 watt chassis mount resistor to be the second stage of the RC filter. So wire for the choke comes up here, goes through this resistor, it comes to this point, and then here's this 100 UF 500 volt cap. This is our ground wire, and then that's our positive. So we pull the positive lead, goes across here over to this little output transformer tag strip that I made, and powers up the two output transformers. So then the plate leads come out of the output transformers, those blue wires, and then we're down here to the tubes. So this blue wire connects to the plate of this tube, and then this is the 100 ohm grid stopper that goes from this point here to the grid of the output tube. And then this is our 270K grid leak resistor. This is a ground wire. Comes up here to both of these 2 points here are grounds. Okay. These 2 wires here go up to the cathode resistor that's sitting on the top of the amp. And it looks like this. So back underneath the amp, again, this is the other ground. Those 2 are the ground sides of the cathode resistors. And then this is the ground that comes over here to this grid leak resistor, 270K. This is the grid, 100 ohm grid. This is the plate, comes over to the output transformer, like that. Okay? So, we wired up these filaments in the last video, but we didn't have these resistors in. These are a couple of 51 ohm, 3 watt resistors that go from this filament to this terminal here, and that creates our virtual center tap of the heater, which is also where we pull the cathode signal off that goes to our cathode resistor. So comes across here, connects to this terminal, and then goes from this bottom terminal down to the cathode resistor that's on the top. So then 880 ohm resistor, ground. Same thing over here, 51 ohm, 51 ohm. This is the center tap. Goes over here, connects to this terminal. And on previous amps, I had used a hum pot, but I realized that with DC heaters, you just really don't need it. And some people connect DC heaters to just one side of the heater, and I think it's quieter and it sounds better pulling it off the center like this. So that's why I put these 2 extra resistors in here. and it also stabilizes the heater voltage. So it's all good stuff. And then finally I got a couple of cathode bypass caps that are going to go across here, and they're going to sit in here. One of them's going to sit like that, and then the other one is going to sit just like that. And I went ahead and put some audio note cathode bypass caps because I want to make sure that what I'm hearing with this amp isn't the capacitors. So I'm putting some nice cathode bypass caps, and I'm going to put the Mundorf coupling caps, and we don't need those anymore. I left those out so you can see the wiring. In here it'd be kind of hard to see with the caps in place. And we're going to use some 0.33 UF Mundorf aluminum wall caps for our coupling caps. And then finally, these two are ground terminals. They have a jumper that goes between the two of them. And then this brown wire comes up and across and comes up here to our star ground point. That's 7 volt AC, so I want to try to keep that away from them as much as possible. So we go up and then down and then around and over here to the ground point. And this thing's ready to power up. So let me go ahead and put the tubes all in this thing, and Dolly's walking upstairs, and I'll check the voltages, make sure all that looks good, and then we'll put this thing on the audio analyzer suite and do some runs on it, looking at the frequency response and the power versus THD and all that sort of stuff with these lower cost parts, and then I'll give this thing a listen. But that's it for building this amp. Okay, so we're gonna get a baseline for a 300B amp using my OG 300B amplifier that has the FC30 output transformers, has Hammond power transformer, has the dual rail power supply. We've got a set of PS Vane Summit tubes, have their 300B and the 6S and 7. And as you can see, it's making really nice power at low distortion. We get up here to 8 watts before we cross basically 2% when you average the channels. And important thing to look at is the input sensitivity is 1.165 volts RMS. And we'll compare that to this other amp. You can see here we're into an 8 ohm dummy load. So we come over to the scope. We put in 1.165 volts RMS, which is 8 watts. And as you can see, there's no clipping. That's at 1K. In both channels, the red and the blue. There's always a little bit of difference between one and the other channel, and it will follow the tubes if I swap them from the left to the right channel. So it's just a little bit of variation in the tubes. Look at the square wave. Super nice. Very flat. It's got a little overshoot on the front, just a tiny bit, which is going to make it sound nice and lively, which this amp does. And otherwise, nothing dramatic to see here. We do our 10K at full power, and I've also tried this at really low power. They look identical. So the power level doesn't seem to impact the square waves at all. And yeah, it's a little wonky here on the front, but it's basically a nice looking square wave for a 10K, and it looks basically like a square wave. It's not, we've seen some really ugly ones checking some of the other amplifiers, and these look reasonable for a 10K square wave on a single-ended amp with no feedback. And then 100 hertz, same thing, full power, and a little overshoot. Got a angle on it, which is what you're normally going to see pulling these things at full power. Just out of curiosity, let's see what this thing looks like at 0.2 volts RMS in. See if that changes anything. Basically the same thing. So then the last thing we're going to look at is the THD versus frequency. And I went ahead and pulled it at just over half of its power level at 4.5 watts, which is where I'm going to be using this thing most of the time. And you can see here, by the time you get to, well, here at 20 hertz, it does have 4.5% distortion. But by the time you get to 30 hertz, it's flat all the way out to 20K. And so here's the second order harmonic distortion. And then you can see it jumps down. We go to third order. And when you look at the THD and then the THD plus noise, not very different. So not a lot of noise in the amp. Most of this distortion is second order. And again, got a little bit of third order distortion, but we're pulling a pretty good power level here. So finally we're going to look here at the frequency response curve. As you can see, this is like crazy flat. And you can see like in this area up here, if you look at that upper right hand corner, that's 0 dB right in this area. And you can see it's just totally flat. When you get down here to 30 hertz, it's down maybe 0.15. And then finally, when you get down to 20 hertz, it's down less than 1/4 of a dB. So that's some really killer low frequency response. And then on the top end, we got the same thing. It's actually even less at 10K. It's still like 0. And as we scroll up here, get up to 20K, it's down less than 1/2 a dB, or a little over 1/2 a dB. But yeah, right there at 18K, you can see there it's 0.4 dB. So definitely got just a killer frequency response. And that's kind of what I've learned to expect from these Tango transformers. So anyway, just wanted to cover this and show you what the frequency response curve looks like. So really nice performance from my OG amp, but I knew it was, and I wanted to include it in this test so that we're not looking at this other amplifier in isolation. So let me hook up this other amplifier and get it warmed up, and we'll see what kind of results we get off of it. Okay, so we got our ultra low cost 300B amp on the Audio Analyzer Suite, and as you can see, the THD looks pretty nice, and it doesn't really have an issue till it gets up to right here at about 6.5 watts, and yeah, it just takes off from there. And I'm pretty sure this is about the area that it starts clipping. And if you notice, this is about 1.5 watts shy of what the amp with the better transformers did, and that had the lower DCR. And yeah, that's what you're giving up here. You're ending up with a 300B amp that really isn't making much more power than my 2A3 amp does, which is kind of what I was afraid of. So we come over here and we look at the frequency response, and we definitely have more low frequency roll off here on the bottom end. Like you can see, if you look at the numbers in the upper right hand corner, right around in here is, almost 0. And when you get down to 30 hertz, it's down 1/2 a dB. And by 20 hertz, it's down a dB. And the Tango iron was definitely less low frequency roll off in this area here, but it's pretty flat frequency response. This is not bad, just it's not what we saw with the other one, and we're running this at a 4.5 watts, but it's taking more volts RMS to get to that same power level, which I noticed when I was listening to this amp before I tested it. I noticed that I had to turn the volume control up higher than I normally do on my amps, because I'm assuming as the output transformers, it's losing some efficiency. So if we go to the scope, Here's our square wave, and you can see at 1.1 volts, just starting to try to clip there on the bottom. And if we go to 1.165, which was 8 watts on the other amp, and no clipping, definitely got clipping on this amp at that power level. So 1.1 is like right up against clipping. So let's look at the square wave, and a little bit overshoot, a little ringing here on the front end, but that's not bad. That's a pretty decent looking square wave. And if we go up to 10K, which to me is more of a test of like how decent are the transformers. That's not a horrible looking 10K square wave for an amp with 0 negative feedback. And then down here at 100 hertz, probably going to see a little more tilt than we had with the Tango iron. Yeah, but still a decent looking square wave. And this is a max power level. So we're going to look at the THD versus frequency, and down here at 20 hertz we've got 7.5% distortion, but by the time it comes down to 40 hertz we're just a little over 1%, and it carries that across the whole frequency range. And then when we look at the second order harmonic distortion versus the third, again, have a little more second order harmonic distortion than third, but not as much as we saw with the Tango iron. The second and third order harmonic distortion is just about even. And you can see that looking down here, like in this area here, the third order is actually a little higher than the second. So the second and third order harmonic distortion is almost even with these transformers. So overall, not bad performance, but yeah, guys, this is just not what I would call a top performing amplifier. And honestly, for the same price point, I could probably build a 2A3 amp that's going to have better performance and make close to the same power, and going to use cheaper tubes, and it's just easier to build. So I'm not sure it makes a lot of sense to try to build these budget 300B amps, which was kind of why we were going through this exercise. I think this may be the only one that I build like this one was built. So anyway, I think that kind of covers what this thing's performance is like, and this is like a great place to wrap up this video. Well, as you can see from the measurements, not quite the performance we were looking for out of this amplifier. And I wanted to also say that I tried at least a half a dozen other output transformers that I had laying around to see if any of them were a good candidate for a 300B amp. I tried a couple of Ed cores, I tried another Musical Power Supplies output transformer, I tried one I got from Thermionic Labs that you may have seen me do a video on when I potted it in a box that I got for it, and none of them came close to what the FC30 ISO, I know sometimes I call them Tangos, but they're ISO FC30 3.5 S2, which is their 300B output transformer. And yeah, you probably notice there's no skunky badge on the front of this amp. It's not going to get one. I'm not going to be building these. And I think you can see from the performance that while these aren't terrible, and maybe, if you're DIYing it, you might want to build one using something like these transformers with the idea that in the future you would replace them with some, ISO units in the future. I'm not going to be selling something at this quality level. I just don't think that it's something that fits my brand and what I want to put out there. And for, the same or less money than I can build this, I can do a 2A3 amp with those nice Habuer transformers. And I tried the Habuer transformers on this 300B. They didn't work good either. There's something about, I'm not sure exactly what's going on. And I'm not an electrical engineer. I don't design vacuum tubes, but I'm finding that a 300B really is picky about the output transformer that's being used, especially single-ended with no feedback. It's probably got something to do with the current being run through them, and that it is, no feedback, and it's got, it's a triode. It's not a pentode that's ultralinear, which puts some feedback in by itself. And you've seen with my ultralinear builds that I always put some shade feedback in them too, which is a form of negative feedback, and they perform great and they sound great. And I've tried using some of that same kind of feedback on a 300B amp, and it just makes it sound dull and flat and just not good. And that was the problem with the Wilsonton R300. While the distortion performance looked okay, they put a ton of global negative feedback in it, and it didn't sound like a 300B amp. And the whole point of building a 300B amp is that it sounds like one. And I'll do more about this in my Monday monologue, but I think there's a reason that 300B amps have gotten hyped up, and it's got nothing to do with the cheap ones. It's that people have listened to really high quality ones, which is historically what 300B amps have been built as, with, really nice output transformers, high quality parts inside them, and then people are hoping to achieve that goodness on a ramen noodle budget. And it's just not going to happen. So, wasn't a total waste. I can take these transformers off. I can put some FC30s on here. I can redo the wiring inside it and convert this into the different power supply. I am working with Matt on finalizing the design on these power transformers. The 6.3 volt was a little too high. It was 6.8 volts, which to me is just right on the edge of that 10% that they say you can have. If it was 6.5 volts or something, I'd probably be okay. So he's going to make me another one as a, follow up to this. I can put some resistors in the circuit and lower that voltage down. So, this could be used, but I would rather have the 6.3 volt rail down closer to 6.6 or 6.4 volts, 6.5, something like that. And so we're doing a slight redesign on these, but I really like the idea of being able to get the 7 volt rails for the voltage regulators in the transformer without having to use a separate filament transformer to power the 300B tubes. And so that's headed in a good direction. I learned some stuff from this. Not sad that I went down this path. I did also put an FC30. You can see this transformer's not bolted down. I did, have a FC30 hooked up, sitting on the bench. Did some testing with it. So this power supply is okay. It's got a little more distortion than that dual rail power supply. And so I don't think I'm going to be doing this simplified kind of power supply in the future either. It's not that much more work to split the power supply after this first choke. It's just one extra resistor, one extra cap, and I really do think it helps with the imaging. And especially with this 300B tubes that are drawing more current. And yeah, I'm not really disappointed. I mean, I guess, I wish this had worked out, but it's not failure unless you don't learn anything from it. And I've learned something from this, that if I'm going to build 300B amps, they're going to be higher end ones that have a FC30 ISO output transformer, can make a full 8 watts of power, because if it's only making 6 or 6.5 watts, you might as well use a 2A3 tube or a modern 2A3 tube. And my little EL34 amp, in my opinion, sounds easily as good as this 300B amp does with these transformers. And I came to that same conclusion when I had the Edcore 25 watt transformers on that OG amp, that it really didn't sound any better than that EL34 amp. And it's a lot cheaper. and use cheaper tubes. And yeah, it doesn't look as impressive. It doesn't have the big, you can't say, oh, I've got a 300B amp. And honestly, if you just want to say that you have a 300B amp, go buy a Rysong A50 and put it on the shelf. And, if you do some mods to it, it'll sound decent, but it's going to be basically what this is. And there's no point in me replicating that at a higher price point. And so this just, to me, doesn't make sense for me to produce these, because it's a lot of work and it's just a mediocre sounding tube amplifier. And my 2A3 amp that's easier to build, I mean, a little bit, it's not that much easier, but you don't have to deal with these DC heaters and the LDO regulators and all that stuff. You just hook up a hum pot and you're good. And they sound really good. So anyway, hope you learned something. I know I did. If you enjoyed this content, please subscribe to the channel. Please like the video. Comment below what you think about this. And, whether you would build one thinking in the future you'd upgrade the transformers or something. I'd be interested to hear what you guys think. I mean, like I said, I don't think it makes sense for me to put this in my product line, and it didn't get the Skunky badge of approval. So anyway, till the next project, y'all have a great day.